Hi guys, Miss Griffin. We're looking at Unit 2, Skill 2 on domain and range. So this should be a review for you because you've talked about domain and range back in Algebra 1. I know some of you it's been a little bit longer than others, but this should be a review. So here's our essential question. How can we determine domain and range? And what symbols are important to know? So as a reminder, the set of inputs, which are your x values, that result in an output is called the domain. So domain is x. And the set of outputs, which are your y values, are called the range. And a quick way that I remember that is the alphabet, just like I remember that for one of the other skills that we've talked about before. X comes before y, so D comes before R. X goes with domain, Y goes with range. So example 1, it says that we have this set of ordered pairs. It's just a bunch of x and y values. X, y, x, y, x, y, x, y. And it says write the domain and range in raster form. That just means like a set. So sets use these curly brackets. And remember that domain is x values, range is y values. So you're literally just listing x values in one set, y values in another. So this would look like 2, 4, 6, 8. And then the y values, 5, 9, 13, 17. Okay, and if there were any repeats, we would not write the repeats. Moving on to example 2, it says state the range of the function f of n equals 2n plus 1 if its domain, so again, x values are 1, 3, and 5. So the domain we can list 1, 3, and 5, and then we're going to find the range. It is asking us to show it as a mapping. So like when we input 1, what's the output? So again, inputs are domain, or x's. Outputs are the range. So this would literally just require us to plug in and evaluate f of 1 equals 2 times 1 plus 1. 2 times 1 is 2 plus 1 more is 3. So when we plug in 1, we get out 3. So literally a mapping shows me 1 goes to 3. Input it as 1, and the output is 3. F of 3 now, because the next x value was 3. So 2 times 3 plus 1 is 7. So we input 3, we output 7. And our last one would be f of 5. Remember, x value always goes in for the parentheses here. So it's 2 times 5 plus 1, which gives us 11. So input 5 and get out 11. Sorry, that little arrow went a little long. Input 5, get out 11. Flipping over to the next page. So now we're going to find it using a graph. We've got y equals g of x shown on the graph below. Answer the following questions based on this graph. Determine the minimum and maximum x values. So if you recall, x's go left to right. So I want to look all the way to the left. What's this furthest left we can go, and all the way to the right. But I actually don't want to draw my box here. We're going to use this box in method to outline this function in terms of where all it goes. Okay, so I put a big box around the highest, the lowest, the furthest left, and the furthest right. So the minimum x value is on the left, and that's going to be, it looks like negative 10. And then the maximum x value is going to be on the right. And that looks like 1, 2, 3, 4, 5. All right, so then we're looking at the min and the max for the y values. So we've got min would be on the bottom. The lowest that this graph goes is way down here at negative 10. And then max would be up at the top. And the highest we go is here at negative 2. And again, this is in reference to the y values going from bottom to top. So then we're asked to state the domain and range using interval functions. So this should still be a review for you, but we're going to go over your symbols, notation, and things like that off to the side over here. So this is for interval notation. So we use these brackets whenever we see a closed circle. And this means that it's inclusive. We have parentheses that get used when we have an open circle. This means it's not inclusive. Then we run into the case where we have negative infinity or positive infinity, which always use parentheses. Okay? And you always want to list these in order from smallest to biggest. So you could have like a combination of parentheses and brackets, or the other way around, brackets then parentheses, or just brackets. And when we talk about domain, remember that it goes from left to right. So your left, for this left goes here, and then for this right goes on the right side, of course. So we read from left to right. For the range, we read from bottom to top. So it's bottom number on the left side and top number on the right side. So that's like max on the right, min on the left. And of course, again, domain is x's and range is y's. Okay? So now we're going to jump back to part C and put all of these things together. So we've got domain and range. Remember again, domain is x, range is y, alphabetical order. Domain goes from left to right. So smallest number on the left side, this took us over here to an open circle at -10. So -10, open circle means not inclusive. So -10 with parenthesis on that side. Comma, on the right side, it took us to a closed circle at 5. So the maximum, the right side, was closed circle at 5. Closed means inclusive, so bracket there. Then when we talk about the range, we go from the bottom. Bottom starts lowest with a closed circle at -10. So bracket -10, comma, and it took us all the way up here. There wasn't an actual circle there though, but this is inferred to be, because it's part of the graph, inferred to be a closed circle. So if you need to, you can put a closed circle right on the graph itself. And this was at the highest point, -2. And that's inclusive, so bracket. Again, closed circle, bracket, open circle, parenthesis, infinity uses parentheses. And I also want to point out, use this little method of putting your furthest left, your furthest right with open and closed circle, furthest top to furthest bottom, open and closed circle. That's going to be super helpful for you. All right, example 4. Some functions defined with graphs or equations have domains and ranges that stretch out to infinity. Consider the following exercise in which a standard parabola is graphed. So we'll get to the parabola in a second, but we want to actually look at example 1 first. Example 1 is just asking us to look at this exponential equation, something like y equals 2 to the x. So I want to start by reading for domain x's that go from left to right, and then we'll do range for y's that go from bottom to top. So when I read this graph from left to right, the furthest left that this goes was way out here, which is actually -infinity. And then as it moves towards the right, we are actually going to expand on forever and ever and ever. This is just climbing very steeply, so we don't really see it on the full graph. Okay, so this goes all the way out to positive infinity. So these are my x's from -infinity to positive infinity, and then I have to figure out brackets or parentheses. And as we just set up above, infinity uses parentheses all the time. Okay, because we don't know where infinity stops. In fact, it doesn't stop, so it's not inclusive. Then for y's, I have to go from the lowest to the top. Well, the lowest that this graph will ever go for this equation, y equals 2 to the x, or any exponential equation for that matter, is 0. And it's actually an open circle at 0 because it's never going to hit 0. If I type this equation into a table, when I see 0, well, I'm not going to see it because it's not ever going to hit it. Okay, so this is 0 up to, well, it's going to reach forever and ever, infinity. So we've got 0, comma, infinity. Infinity, I know, uses parentheses. This never actually hits the graph at 0, so it's not inclusive, meaning it's a parenthesis. Okay, so this was our range. and this was our domain. Now we're going to do the same type of thing, but this time for a quadratic equation. So domain again is x's, range is y's. X's go from left to right. So how far to the left does this graph go? Well, it's not where the graph paper stops, so please don't mistake that. It's not where you see this little piece of the graph, the actual function stopping. It's what I notice by these arrows. These arrows tell me that it keeps going to the left to negative infinity. And then as we go this way, we are moving right forever and ever and ever. We're just rising at a very steep rate, so we're not really going to see it too much. The arrow tells me that we keep going to the right to positive infinity. So this domain is actually the same as the last graph that we saw. Negative infinity to positive infinity, and we've got parentheses. Then when I look at my range, I start from the bottom and I go up, up, up to the top. Well, the bottom is a closed circle because it's part of the graph. And again, this is for my range. Closed circle, part of the graph starts at 3. So it starts at 3 and goes up with these arrows. These arrows mean that it keeps going forever and ever and ever to infinity. So parentheses on the infinity, but this closed circle tells me that I want to include the 3. So square bracket. Flip it over, we'll see another example or two. All right, so here we've got another function where we're talking about domain and range. This is a square root function. You have to know the difference between these types of functions and how their domain and range works because they are different for each one. So domain, again, x's, range, y's. Domain goes left to right. So I look at my graph and I'm scanning to the left and I notice that it stops here. And it's a closed circle at -4. And then as I move to the right, this keeps going forever and ever and ever. So we've got -4 with a closed circle, so that's bracket, comma, infinity, which must be a parenthesis. And then when I look at my range, starting from the lowest value, going up to the highest, well, the lowest it can go is a solid circle or closed circle. And then going upwards. It's climbing very slowly, but eventually it's going to get all the way up to infinity. So I know it's going up to infinity. The lowest in terms of y's that we can go is actually 0. So it's closed circle on 0, meaning a bracket, comma, infinity with a parenthesis. Okay, so this is our range, and this is our domain, so that you have those labels in case you need to look back at it. Domain goes left to right, range goes bottom to top. All right, so we're going to read this little piece here. It says, for most functions defined by an algebraic formula, the domain consists of the set of all real numbers, given the concise symbol with this R. That R means all real numbers. So maybe you want to underline or highlight this part. The set of real numbers is that R. It's fancy. Looks like this. Okay? So then it says, sometimes though, that there are restrictions placed on the domain of a function by the structure of its formula. Two basic restrictions will be illustrated in the next few exercises. So we've got this function, f of x equals, and then it's a fraction. Okay, so a ratio here. And it has outputs given by the calculator's table. So somebody typed this into a calculator, and then we look at the table here. Remember, this is just x and y. F of x is the same thing as y. And then I noticed that it gives us an error at x equals 4. Well, if we plug in x equals 4, so that would be 2 times 4 plus 1 divided by 4 minus 4. So the numerator is 9, the denominator is 0. This is an issue. Okay, so it gives us an error because when x equals 4 is plugged in to f of x, denominator equals 0, which makes the function undefined. Ooh, that's a horrible job of writing the word which. So again, when the denominator is 0, that's a bad thing. Denominator can never be equal to 0. Okay? So that's a restriction on this domain. because if the denominator comes out to be 0, then that x value, the domain value, cannot be included. So then it says, are there any other values except x equals 4 that are not in the domain of f? Well, we just want to look at the denominator, x minus 4, and test to see when it's equal to 0. So that means x, well, if I add 4 to both sides, x equals 4 is the only number that would make the denominator equal to 0. So we say no, 4 is the only value that makes the denominator equal to 0. All right, 2 more little questions on the back side, I think. All right, so exercise 6, which of the following values of x would not be in the domain of the function y equals square root x plus 4? So this is a square root function. And as you guys know, underneath a square root, as we've talked about in the Unit 1 stuff, underneath a square root needs to be greater than or equal to 0, meaning it can't be negative overall. Okay, so let's write that little phrase off to the side. No negatives under the square root. So it can start as like plugging in a negative, but overall the final number under the square root cannot be negative. So we've got to figure out which one of these would give us a negative underneath there. So if I plug in x equals 0, this would be 0 plus 4. Well, square root of 4 is okay. All right, because it's not a negative. 4 is a positive value. All right, so let's try this. 5 plus 4 under the square root. This gives us square root 9. That's okay, because 9 overall is positive. Square root of negative 3 plus 4. This gives me square root of 1. That's okay because 1 is positive. But when I test this one, negative 8 plus 4, this gives me square root of negative 4. This is not okay because there's a negative underneath overall. So x equals 8, or negative 8. When plugged in, we get a negative number under the square root. So we have to explain our answer, so we're just going to say exactly that. If x equals negative 8 is plugged in, we get the square root of a negative number. So x equals negative 8 is not in the domain. Okay, these next couple are actually practice problems for you. You try, and then hit play to check your answers or to hear an explanation. Okay, so you try these before you walk away to do your practice problems. Okay, so I've got my answers here. You can check them real quick, but I'm also going to explain them. So in number 1, it says the function is defined by x squared minus 3 with the domain given by this set. So they give us a set of x values here. Domain is x, and it asks us to write the set that represents the range, being the y values. So I made a little table. And in my calculator or in my head, I did this little operation. Plug in the x value, so y equals parentheses negative 2 squared, and then minus 3. And that gives me positive 1. Okay, so that's my process for each one of these. Input the x value, and then the output is the y value. And so then from here, I'm looking to just write the set that represents the range. So take all these y values and put them in a set. So that's just curly brackets listing the numbers. But then as I listed them, I noticed that I repeated negative 2 and positive 1. So we don't actually need repeats. You don't want to write them in there. So I just condensed the set to be negative 3, negative 2, and positive 1. And just like you write solutions for, say, a quadratic equation that you're solving, you want to put these in numerical order if you're able. Okay, so smallest number first, biggest number second. In number 2, it says that we've got this function 4x minus 7 with a domain inclusive of negative 2 all the way up to 7. So when I made my table, I went from negative 2 all the way up to 7. Okay, I found my y value, same process. I take the x value, say negative 2, and I plug it into the equation. And when I do that, it gives me y equals negative 15 in this problem. Okay, so I did not show the work for that, and that's okay. You can easily do this in a calculator or using the graph function of your calculator. Type this into the graph and then pull up the table. Okay, so I've got these numbers in blue as my range, my y values. And I notice that the smallest one is negative 15, and the highest one happens to be 21. So they want me to write the range as an interval. Intervals, remember, are using those curly brackets, or not the curly brackets, the parentheses or square brackets. But I know that I was inclusive here with negative 2 to 7, which means that this would be a solid dot going to a solid dot, a closed circle. Okay, which means that these have to be square brackets from the lowest to the highest. And we can include any number in between those, even if it wasn't listed, because I could be including a negative 1.5 here, which would give me a different answer here. That's not included with the numbers I listed already. It's in between them. All right, make sure that you answer the questions at the bottom of your packet. This is your summary section now. So summaries, we are now prompting you, figure out what circle you need for each of these symbols, figure out what you need for positive and negative infinity. Domain is blank values like x or y. We move from blank to blank, up to down, left to right, right to left. Figure it out, fill it in, and then make sure that we check it after you've done your practice problems. Okay? Have a good one. Goodbye.